There is a place where the sun is nothing more than a bright star. It is a realm of eternal night, where temperatures hover near absolute zero, where the very air freezes and falls to the ground like snow. It is the edge of the known solar system, the boundary between the planets we know and the icy chaos of the Kuiper Belt. For decades, we looked at this place and saw only a dot, a smudge of light on a photographic plate, a mathematical curiosity. We called it Pluto. We thought we knew what it was: a dead rock, a frozen wasteland, a tomb of ice drifting in the darkness. We thought it was geologically dead, frozen solid since the birth of the solar system, preserved in the deep freeze like an insect in amber. We thought nothing could live there. We thought nothing could move there. We thought it was safe, but we were wrong. In July of 2015, a machine built by human hands flew past this distant world. It was called New Horizons. It had traveled for 9 years, 3 billion miles, through the vacuum of space to catch a glimpse of the king of the Kuiper Belt. When the data finally arrived, when the images were downloaded, when the scientists at NASA unpacked the secrets sent across the void, they did not find a dead world. They found a world that was alive. They found mountains that should have collapsed. They found glaciers that should have frozen. They found an ocean that should not exist. And they found something else, something hidden in the data, something that whispered of processes we do not understand, of energy sources we cannot explain, of possibilities that terrify the human mind. This is not a story about aliens. This is not a story about science fiction monsters lurking in the ice. This is a story about physics. It is a story about the laws of thermodynamics being broken in the dark. It is a story about a world that defies its own existence. When NASA looked at Pluto, they expected to see a corpse. Instead, they found a heartbeat. And that heartbeat raises a question that keeps astronomers awake at night. If Pluto is alive, what else is out there in the dark? If a world so far from the sun can generate heat, can move its crust, can sustain an ocean, then the habitable zone of our solar system is not a narrow ring around the sun. It is everywhere. The darkness is not empty. It is full, and it is watching. The discovery was terrifying not because of what it was, but because of what it implied. It implied that our models of planetary formation are wrong. It implied that energy can be generated in ways we did not predict. It implied that life, or the precursors to life, could exist in the most hostile environments imaginable. It implied that we are not alone in the solar system, not necessarily in the sense of intelligent beings, but in the sense of living worlds. Worlds that breathe, that shift, that change, worlds that are hidden in the cold. To understand the terror, we must first understand the expectation. We must understand why Pluto was supposed to be dead. We must understand the journey to get there. We must understand the silence that preceded the discovery. Because the shock of the discovery is only measurable against the depth of the certainty that came before. We were sure. We were so sure. And then the data came back, and the certainty shattered. This narrative will take you through the history of Pluto. It will take you through the construction of the spacecraft. It will take you through the moments of the flyby. It will analyze the geology, the chemistry, the physics. It will examine the anomalies. It will confront the theories. And it will ask the ultimate question: what is powering Pluto? What is keeping the heart beating in the dark? The answer is not simple. The answer is not comfortable. The answer changes everything we know about our place in the cosmos. We are about to look into the abyss, and the abyss is looking back. Chapter 1: The ninth planet that wasn't the story of Pluto begins not with discovery, but with obsession. In the late 19th century, the solar system was thought to be complete. We had the 4 inner rocky planets. We had the 4 outer gas giants. We had the asteroids. We had the comets. But there were anomalies. The orbit of Uranus did not match the predictions of Newtonian physics. It wobbled. It deviated. This suggested the gravitational pull of another body, something unseen, something distant. Percival Lowell, a wealthy astronomer with a fascination for Mars and canals, turned his attention to the outer darkness. He called it Planet X. He spent the last years of his life searching for it. He died without finding it. But his observatory, Lowell Observatory in Flagstaff, Arizona, continued the search. In 1930, a young farmer named Clyde Tombaugh was hired to take photographs of the night sky. He used a blink comparator, a device that allowed him to switch between 2 photographic plates of the same region of the sky taken on different nights. If a star moved, it was not a star. It was a planet. For months, he blinked. Thousands of stars, millions of points of light. And then, on February 18th, 1930, he saw it. A tiny dot that had shifted position. It was faint. It was distant. It was Pluto. The discovery captivated the world. Here was the 9th planet, the edge of the system. But as the decades passed, Pluto became more of a mystery than a solution. It was too small. It was too light. Its orbit was tilted, inclined 17 degrees to the ecliptic plane, crossing inside the orbit of Neptune. It did not fit the pattern of the other planets. It was an outlier, an oddity. And as our technology improved, as our telescopes became more powerful, we found more objects like it. Eris, Makemake, Haumea. The Kuiper Belt was not empty, it was crowded, and Pluto was just one of many. In 2006, the International Astronomical Union made a decision that shattered the childhoods of millions. Pluto was demoted. It was no longer a planet. It was a dwarf planet, a member of the Plutino class. The 9th planet was gone. The solar system had 8 planets. The decision was controversial. It was painful. But scientifically, it was necessary. Pluto was not a dominant body. It was a king of the ice dwarfs. But this demotion did something else. It relegated Pluto to the background. It became a forgotten world, a distant curiosity. Why spend billions to visit a dwarf planet? Why send a mission to the edge of nowhere? The scientific community was divided. Some argued that Pluto was just a big comet, a ball of ice and rock that was not worth the expense. Others argued that Pluto was the key to understanding the formation of the solar system. It was a relic, a fossil, a preserved sample of the early solar nebula. If we wanted to know how planets formed, we had to go to the edge. We had to see what the building blocks looked like. The argument for exploration won, but barely. The New Horizons mission was approved, but it was fraught with danger. It was a risky endeavor, a long shot. The distance was the first enemy. Pluto is an average of 3.7 billion miles from Earth. Light takes 5.5 hours to travel that distance. A radio signal sent to Pluto takes 5.5 hours to arrive. A response takes 5.5 hours to return. A single conversation takes 11 hours. There is no real-time control. There is no joystick. Once the spacecraft was launched, it was on its own. If something went wrong, if a computer froze, if a thruster failed, there was no way to fix it. The engineers had to anticipate every possible failure. They had to code every possible contingency. The spacecraft had to be smart. It had to be autonomous. It had to be able to save itself. The second enemy was time. To reach Pluto in a reasonable time frame, the spacecraft had to move fast, very fast. New Horizons was launched on the fastest rocket ever built for a planetary mission, the Atlas 5551. It left Earth at 36,000 miles per hour. It was the fastest object ever launched by human hands. But even at that speed, it would take 9 years to reach Pluto. 9 years of silence, 9 years of hibernation, 9 years of drifting through the void. The third enemy was power. At Pluto, the sun is 1,000 times fainter than it is at Earth. Solar panels would not work. They would be too large, too heavy, too inefficient. The spacecraft had to rely on nuclear power. A radioisotope thermoelectric generator, or RTG, plutonium-238 decaying into heat, converted into electricity. But plutonium is scarce. It is dangerous. It is expensive. The supply was limited. The mission had to be efficient. Every watt counted. Every instrument had to justify its power consumption. The fourth enemy was the cold. Space is cold, but the outer solar system is colder. The instruments had to be kept warm. The electronics had to be protected. The fuel had to not freeze. The spacecraft was wrapped in gold foil, insulated like a thermos. But the heat from the RTG was limited. It had to be managed. It had to be distributed. The thermal design was a masterpiece of engineering, but it was a constant struggle against the entropy of the universe. And the fifth enemy was uncertainty. We did not know what we would find. We knew Pluto had an atmosphere, a thin veil of nitrogen, but we did not know how dense it was. We did not know if it would freeze out onto the surface. We did not know if there were rings, debris, dust. If New Horizons flew into a ring of dust at 36,000 miles per hour, it would be sandblasted into oblivion. The spacecraft would be destroyed. The mission would be lost. There were plans to change the trajectory at the last minute, to aim for a safer path. But that would mean missing the best science targets. It was a gamble, a bet against the unknown. The team accepted the risk. They built the spacecraft. They tested it. They launched it. And then they waited. For 9 years, New Horizons slept. It woke up only once a year to check in, to send a beacon tone. Green means good. Yellow means caution. Red means danger. For 9 years, the tone was green, but the silence was heavy. The distance was vast. The team aged. The scientists retired. The students graduated. And Pluto waited. It drifted in the dark, unchanging, unmoving, dead, or so we thought. The demotion of Pluto had made it an underdog, a rejected world. And perhaps that made the mission more poignant. We were going to visit the outcast. We were going to see the world that was not good enough to be a planet. We were going to prove that size does not matter, that distance does not matter, that even the smallest, farthest world deserves to be known. But beneath the sentimentality, there was science. Hard, cold science. We needed to know what Pluto was. We needed to know what the Kuiper Belt was. We needed to know how the solar system formed. But there was also a deeper curiosity, a human need to explore, to go where no one has gone, to see what is over the horizon. Pluto was the horizon. It was the edge of the map. Beyond it lay the interstellar medium, the space between the stars. Pluto was the last stop, the final outpost. Once we passed it, we would be looking outward, into the galaxy, into the void. So this mission was not just about Pluto, it was about closure. It was about finishing the reconnaissance of our own cosmic neighborhood. It was about knowing our home. And so, the spacecraft traveled, past Jupiter, past Saturn, past Uranus, past Neptune, each milestone marked on a timeline, each gravity assist used to shave off time. The trajectory was precise, down to the kilometer, down to the second. The navigation team calculated the burns, the propulsion team executed them. The spacecraft held its course. It was a spear thrown into the darkness, and it was flying true. As it approached Pluto, the anticipation grew. The images began to come in. Low resolution, blurry blobs. But they were getting better. Each week, the resolution doubled. Each day, the details sharpened. The team gathered in the control room. The scientists held their breath. The engineers monitored the telemetry. Everything was nominal. The spacecraft was healthy. The instruments were ready. The encounter was days away, hours away, minutes away. And then, the silence. During the flyby, the spacecraft would not talk to Earth. It had to focus on the science. It had to point its instruments. It had to collect the data. It had to store it on the solid-state recorders. There was no bandwidth to send it back in real time. It had to record everything, then turn around and send it home. Slowly, bit by bit. It would take a year to download all the data. So when the flyby happened, there was no live feed. There was no cheering. There was only waiting. The spacecraft went silent. It passed behind Pluto. It emerged. It sent the beacon. Green. It was alive. It had survived. But what had it seen? What had it found? The world waited. The data trickled in. A few images, then more, then the high-resolution ones. And when they appeared on the screens, the room went quiet. Not with joy, but with shock, with confusion, with fear, because what they saw was impossible. Chapter 2: The 9-Year Silence. To appreciate the shock of the discovery, one must understand the duration of the silence. 9 years is a long time in human life. It is a decade, -1. It is enough time for a child to become a teenager, for a technology to become obsolete, for a world to change. During those 9 years, New Horizons was alone. It was the farthest human-made object from Earth, until Voyager surpassed it again. It was a solitary traveler. It carried the ashes of Clyde Tombaugh, the man who discovered Pluto. A small canister of cremated remains mounted on the spacecraft. A passenger on the journey home. It was a poetic gesture. The discoverer returning to his discovery. But it also added a weight to the mission. This was a pilgrimage, a funeral, a homecoming. During the cruise phase, the spacecraft was in hibernation. It spun like a top. It slept. It woke up once a year for a system check. The engineers would send commands. The spacecraft would respond. It would test its instruments. It would calibrate its sensors. It would update its software. And then it would go back to sleep. For the rest of the year, it was silent. Just the beacon tone, a pulse once a week, a heartbeat in the dark. The team monitored this tone. If it stopped, if it changed, if it went yellow or red, there would be panic. But it remained green, steady, consistent, a promise that the machine was still working. But the silence was not empty. It was filled with anxiety. Space is hostile. Radiation can flip bits in the computer. Micrometeoroids can puncture the hull. The RTG can degrade. The fuel can leak. There were hundreds of single-point failures, things that could kill the mission instantly. And there was no way to fix them. The team had to rely on redundancy, on backup systems, on clever coding. They had written software that could detect errors and correct them, that could switch to backup computers, that could put the spacecraft into safe mode if something went wrong. But safe mode meant stopping the science. It meant turning away from the target. It meant waiting for instructions from Earth. And at Pluto, waiting meant missing the opportunity. There would be no second chance. The trajectory was a one-time shot. If you miss the flyby, you miss it forever. So the tension was constant. Every year, the check-in was a relief. Every year, the spacecraft survived another lap around the sun. But as it got closer to Pluto, the checks became more frequent. The hibernation periods shortened. The spacecraft woke up more often. It began to prepare. It loaded the sequences. It tested the instruments. It pointed the antenna. It practiced the maneuvers. It was like an athlete before the big game, warming up, stretching, focusing. The team on Earth was also preparing. The control room at the Johns Hopkins University Applied Physics Laboratory in Laurel, Maryland, was upgraded. The screens were replaced. The software was updated. The people were trained. Simulations were run. What if the spacecraft loses lock on the star tracker? What if the data recorder fills up? What if the transmitter fails? They played out every scenario. They practiced the responses. They drilled the procedures. They were ready for anything, except what they actually found, because the preparation was based on models. Models of Pluto's atmosphere, models of Pluto's surface, models of Pluto's geology. These models were based on telescopic observations, Hubble images, ground-based spectra, light curves. They were good models, the best we had. But they were low resolution. They were blurry. They were indirect. We knew Pluto had nitrogen ice. We knew it had methane. We knew it had carbon monoxide. We knew it had a thin atmosphere. We knew it had a moon, Saturn. And Charon had moons of its own. Nix, Hydra, Kerberos, Styx. A complex system, a mini solar system. But we did not know the surface details. We did not know the topography. We did not know the age. We assumed it was old, cratered, like the moon, like Mercury, like the other dead worlds. The logic was simple. Pluto is small. Small bodies cool fast. If it cooled fast, the interior froze. If the interior froze, there was no heat. If there was no heat, there was no geology, no volcanoes, no earthquakes, no movement. The surface should be static, preserved, a record of impacts over billions of years. The more craters, the older the surface. We expected to see a lot of craters. We expected to see an ancient world. This expectation was the baseline, the null hypothesis. Pluto is dead. Any deviation from this would be significant. Any sign of activity would be surprising. Any sign of heat would be shocking. The team was prepared for surprises, but they were not prepared for a revolution. They were prepared for tweaks to the model, not a complete overhaul. They expected to fill in the blanks, not to erase the page. The journey also took them through the Kuiper Belt, the region beyond Neptune, a disk of icy bodies, remnants of the solar system's formation. New Horizons was tasked with studying this environment, the dust counter, the particle detector, the plasma sensor. They were looking for the density of the material, the composition of the dust, the interaction with the solar wind. This data was important. It would tell us about the environment Pluto lived in, but it was secondary. The primary target was Pluto, the king of the Kuiper Belt. As the spacecraft approached, the data began to change. The dust counts were lower than expected. The environment was cleaner. That was good news. Less risk of impact. But it was also strange. Why was it so clean? Where was the debris? The Kuiper Belt was supposed to be crowded, but New Horizons was finding it empty. This was the first hint, the first anomaly. The models of the Kuiper Belt were wrong. The density was lower. The collision rate was lower. This meant the objects there were older, less processed, more pristine. But it also meant Pluto was more isolated than we thought. It was alone in the dark. The atmosphere data also began to shift. As the spacecraft got closer, it could measure the atmospheric pressure. It was lower than expected. The atmosphere was collapsing, freezing out onto the surface. As Pluto moved away from the sun in its elliptical orbit, it was getting colder. The nitrogen was condensing. The atmosphere was thinning. This was predicted, but the rate was faster than expected. The atmosphere was dying, or so it seemed. This added to the picture of a dead world, a world in winter, a world shutting down. The images began to resolve. The blob became a disk. The disk showed features, dark regions, light regions, a mottled surface. There was a large bright spot, a heart shape. It was visible from millions of miles away. It was distinct, unique. No other world looked like this. It was intriguing. But still, the expectation was death. The heart was just ice, just a deposit, just a stain. It was not an organ. It was not a symbol. It was just geology. Or so we thought. The silence of the 9 years was an incubation period. For the technology, for the team, for the expectations. We had built a picture of Pluto in our minds, a cold, dead, cratered rock. We had lived with this picture for decades. It was comfortable. It made sense. It fit the models. And then the flyby happened. The data started to flow, and the picture shattered. The silence was broken, and what spoke from the darkness was not what we expected to hear. Chapter 3, The Awakening, July 14th, 2015. The date is etched in the memory of every planetary scientist. It was the day New Horizons made its closest approach to Pluto. The distance was 12,500 kilometers, about 7,700 miles. Closer than the moon is to Earth, the spacecraft was moving at 30,000 miles per hour. It had one chance to capture the data. The sequence was automated. Turn, point, shoot, store, turn, point, shoot, store. There was no human intervention. The light time was 4.5 hours. By the time the signal reached Earth, the spacecraft was already moving away. It was already past the target. It was already on its way to the Kuiper Belt. The control room was tense. People held their breath. The clock counted down. The telemetry scrolled across the screens. Status codes, temperatures, voltages, everything green. The spacecraft was performing perfectly. It was executing the script. The high-gain antenna was pointed away from Earth. It was pointing at Pluto, so there was no data coming down, just the status of the spacecraft itself. We knew it was working, but we did not know what it was seeing. We had to wait. The closest approach came and went. The spacecraft survived. It did not hit any dust. It did not freeze. It did not fail. It sent the beacon. Green. The room erupted, cheers, tears, hugs. It was a triumph of engineering, a victory of human will. We had reached the edge. We had touched the void. But the science had not yet begun. The data was on board, stored in the memory. Now came the download. The download was slow. The bandwidth was limited. 1 kilobit per second. Slower than a dial-up modem. It would take a year to send it all. So the team prioritized. They wanted the best images first. The ones taken at closest approach, the high-resolution ones, the ones that would show the surface details. They compressed the data. They sent it in packets. They waited for the acknowledgement. It took hours to get a single image, and then it appeared on the big screen in the control room. The first high-resolution image of Pluto. The room went silent. Again, but this time it was not tension. It was disbelief. The image was sharp, clear, detailed, and it showed no craters. In the region of the heart, the bright region, Tombaugh Regio, there were no craters, none, 0. A surface with no craters is a surface that is young, geologically young, less than 100 million years old. In a solar system that is 4.5 billion years old, 100 million years is nothing. It is yesterday. It is today. It means the surface is being renewed. It means something is erasing the craters. Something is active. This was the first shock, the first crack in the model. Pluto was not dead. It was alive, geologically alive. But how? What was powering it? There was no sun. There was no tidal heating from a giant planet like Io. There was no radioactive decay sufficient to melt the ice. The energy budget did not add up. The physics did not work. But the evidence was there, on the screen, in front of their eyes. A smooth plain of nitrogen ice, Sputnik planitia, the left lobe of the heart. It was cellular, polygonal, like mud cracks, like boiling water. It was convecting. The ice was moving, churning, overturning. The surface was being recycled. The scientists stared at the image. They checked the calibration. They checked the metadata. They checked the processing. Was it a glitch? Was it an artifact? No, it was real. The data was solid. The conclusion was inescapable. Pluto was active, but the mechanism was unknown. It was a mystery, a terrifying mystery. Because if Pluto was active, then our understanding of heat transfer in small bodies was wrong. If Pluto was active, then other Kuiper Belt objects could be active. If Pluto was active, then the outer solar system was not a graveyard. It was a nursery. The images kept coming. Each one brought new surprises. The mountains, water ice mountains, rising 3.5 kilometers high, higher than the Rockies, made of water ice, which at Pluto temperatures is as hard as rock. But they were sharp, jagged, young. Old mountains erode. They slump. They collapse. These mountains were standing tall. They were recent. They were formed recently. But how? What lifted them? What pushed them up? There was no plate tectonics, no continental drift, no volcanism in the traditional sense. But there was uplift. There was construction. The color was another shock. Pluto was not gray. It was not white. It was red. A deep, rusty red. The color of tholins, complex organic molecules, created by radiation hitting methane and nitrogen, the stuff of life, the precursors to amino acids. Pluto was covered in the building blocks of life. It was not just active. It was chemical. It was complex. It was organic. The darkness was not sterile. It was rich. It was fertile. The atmosphere was another surprise. It was not collapsing as fast as we thought. It was still there, still hazy, still blue. The sunlight scattered through the haze layers. It was beautiful. But it was also puzzling. Why was it still there? Why had it not frozen out? There was a source. Something was replenishing the atmosphere. Something was outgassing. Something was keeping the pressure up. The moons were also active. Charon, the largest moon, had a red pole, a dark cap, tholins again. But it also had canyons, deep chasms, 4 miles deep, longer than the Grand Canyon. It had been torn apart. It had expanded. The interior had frozen and cracked the crust. It was a world of violence, of stress, of change. Every image was a contradiction. Every data point was a puzzle. The team was overwhelmed. They had expected to write a paper confirming the models. Instead, they had to rewrite the textbooks. They had to invent new physics. They had to propose new mechanisms. They had to admit that they did not know. The awakening of Pluto was not just a scientific event, it was a psychological one. It changed how we saw the solar system. It changed how we saw the universe. It showed us that activity is not limited to the inner planets, that heat is not limited to the sun, that life is not limited to the earth. It showed us that the darkness is not empty. It is full of potential, full of energy, full of secrets. But with the awakening came the fear of the unknown. If Pluto is active, what is driving it? Is it natural? Is it exotic? Is it something we do not understand? The data was clear. The interpretation was not. The scientists debated. They argued. They proposed theories. But none of them fit perfectly. None of them explained everything. There was a gap, a missing piece, a variable we had not accounted for. And that gap was where the terror lay, in the unknown, in the unexplained, in the possibility that there was something else at work. Chapter 4. The Heart of the Darkness, Tombaugh Regio. The heart. It is the most iconic feature on Pluto, a bright heart-shaped region on the equator. It is about 1,000 miles across. It is made of nitrogen, ice, but it is not just a deposit. It is an engine. The left lobe, Sputnik Planitia, is a vast glacier, a basin filled with frozen nitrogen. It is smooth, flat, cellular. The polygons are about 20 miles across. They are convection cells. The ice is boiling, not with heat like water on Earth, but with heat from below. The nitrogen ice is solid, but it is viscous. It flows, it moves, it overturns. The center of the cell rises. The edges sink. The surface is renewed every 500,000 years. This is fast. Geologically fast. It means the surface is young. It means the ice is moving. But why is it moving? Nitrogen ice is soft. It flows at low temperatures, but it needs energy to flow. It needs heat. Where is the heat coming from? The sun is too far. The radioactive decay in the core is too weak. There must be another source. Some scientists propose antifreeze, ammonia, methanol, lowering the melting point of the water ice below, creating a subsurface ocean. But even with antifreeze, the heat budget is tight. It is borderline. It requires fine-tuning. It requires conditions that are unlikely. But there it is, boiling, churning, alive. The heart is also a climate engine. It drives the winds on Pluto, the nitrogen sublimates on the sunlit side. It flows to the dark side. It condenses. It creates pressure gradients. It creates winds, blasting across the surface at hundreds of miles per hour, shaping the dunes, moving the dust, creating the streaks. The heart beats. It pumps atmosphere. It circulates gas. It is a meteorological system. on a world that should have no weather. The position of the heart is also strange. It is almost exactly on the equator, opposite Charon, the tidal lock. This suggests a reorientation, a true polar wander. Pluto spun on its axis to align the heart with the tidal axis. This means the heart is a mass anomaly. It is heavier than the surrounding crust, or lighter, depending on the model. But it caused the planet to tip, to reorient. This requires a flexible interior, a subsurface ocean, a decoupling of the crust from the mantle. If Pluto is rigid, it cannot reorient. If it has an ocean, it can. The heart tells us there is an ocean. The ocean is the key, the subsurface ocean, a layer of liquid water beneath the ice, salty, ammonia-rich, kept liquid by pressure and heat. It is the engine of the activity. It drives the cryovolcanism. It drives the convection. It drives the reorientation. But the ocean should have frozen billions of years ago. It should be solid, but it is not. It is liquid. Today? Now? How? What is keeping it warm? The theories vary. Some say radioactive elements, potassium, thorium, uranium, concentrated in the core. But the models say it is not enough. Some say tidal heating, but the orbit is circular. The tides are weak. Some say impact heating. A large collision created the heart, melted the ice. But that was billions of years ago. The heat should have dissipated. Some say clathrates, gas hydrates, insulating the ocean, keeping the heat in, like a blanket. This is the leading theory, a layer of gas ice below the surface ice, trapping the heat. But it is speculative. It is unproven. The heart is also a trap. It collects the volatiles, the nitrogen, the methane, the carbon monoxide. It is a cold trap, the lowest point. The ices flow into it. They accumulate. They build up. They press down. They depress the crust. They create the basin. It is a dynamic system, a cycle. The ices move. The crust flexes. The ocean responds. It is a living world. But the heart is dark. Literally. The edges are dark. The tholins settle there. The radiation creates the red stuff. It rings the heart, like a border, like a stain. It makes the heart stand out. It makes it look organic, like a biological organ. It is unsettling. It looks like a heart. It beats. It pumps. It bleeds red. It is a metaphor made real. The heart of the darkness. The discovery of the heart changed the narrative. Pluto was no longer a rock. It was a world, a complex world, a system. It had geology, it had meteorology, it had chemistry, it had history, it had a present, it had a future. It was not a fossil, it was a participant. But the heart also hid secrets. The data from the heart was the most detailed, the most analyzed. And it was where the anomalies were found, the temperature variations, the spectral signatures, the unexplained emissions. The heart was the source of the terror, not because it was evil, but because it was unknown, because it defied the models, because it suggested something deeper, something hidden beneath the ice. The scientists spent years studying the heart. They mapped the polygons, they measured the flow rates, they modeled the convection, they tried to match the observations. But there were residuals, differences, things that did not fit, small things, but significant. A heat spot here, a composition there, a movement that was too fast, a signal that was too strong. These were the whispers, the hints, the clues that there was more to the heart than just nitrogen ice. The heart of the darkness was not just a geological feature, it was a symbol of the unexpected, of the hidden, of the alive. It showed us that even in the coldest place, there is warmth. Even in the darkest place, there is light. Even in the deadest place, there is life. But it also showed us that we do not understand the source. We do not understand the engine. We do not understand the power. And that lack of understanding is the root of the fear. Chapter 5: The Mountains That Shouldn't Exist. When New Horizons sent back images of the mountains on Pluto, the geologists were confused. They were water ice mountains. Water ice is the bedrock of Pluto. At 40 Kelvin, it is as hard as granite. It does not flow. It does not erode. It stands. But it should not be there. Mountains are formed by tectonics, by collision, by uplift. Pluto has no plate tectonics. It has no moving plates. It has no continental drift. So how did the mountains form? The Norgay Montes, the Hillary Montes, named after the peaks of Everest. They rise high above the plains. They are jagged, blocky, young. They show no signs of erosion, no wind-blown dust, no sublimation pits. They are fresh. They were formed recently, but how? What pushed them up? One theory is cryovolcanism, ice volcanoes, erupting water ice instead of molten rock, pushing the mountains up, like domes, but there are no calderas, no flow features, no vents. They look like tectonic blocks, like fault mountains, but there are no faults, no plate boundaries. Another theory is impact. A large impact created the Sputnik-Planitia Basin. The rebound created the mountains, like the peak ring of a crater. But the mountains are too far away, too distributed. They do not fit the impact model. Another theory is contraction. The interior froze, the planet shrank, the crust cracked, the blocks pushed up, like ice on a freezing pond. But the planet should have expanded if the ocean froze. Ice is less dense than water. It should have swollen, not shrunk. The mountains are a paradox. They exist, but they should not. They require energy. They require force. They require movement. But the energy budget does not allow it. The force is not there. The movement is not possible. But they are there, standing tall, defying the physics. The composition is also strange. They are water ice, but they are covered in methane frost. The methane condenses on the peaks, like snow on Earth. But the methane comes from the atmosphere. It falls like snow. It coats the mountains. It makes them bright. But the water ice below is dark. It is old. It is irradiated. The contrast is sharp. The peaks are white. The valleys are dark. It is beautiful. But it is also puzzling. Why does the methane only settle on the peaks? The atmospheric models say it should settle everywhere. But it does not. It prefers the high ground. It is a mystery. The mountains also tell us about the interior. They require a rigid crust, a thick shell, to support the weight. If the crust was thin, the mountains would sink. They would isostatically adjust. They would float. But they are high. They are supported. This means the crust is thick, 10 miles, 20 miles, of water ice. But if the crust is thick, how does the heat get out? How does the ocean stay liquid? The insulation is too good. The heat should be trapped. The ocean should boil or freeze. It is a balancing act, a fine line. And Pluto is walking it. The mountains are also evidence of stress. The crust is under tension or compression. The faults show the direction. The blocks show the movement. The stress is global. It is not local. It is the whole planet. It is squeezing or stretching. It is changing shape. It is evolving. It is not static. The existence of the mountains is a testament to the activity of Pluto. It is not a dead world. It is a world of force, of power, of change. But the source of the power is unknown. It is the same mystery as the heart, the same anomaly, the same terror. Where is the energy coming from? What is driving the tectonics? What is lifting the mountains? The scientists looked at the mountains and saw the impossible. They saw the violation of the models. They saw the gap in the knowledge. They saw the unknown, and they were afraid, not of the mountains themselves, but of what they represented: the failure of the physics, the inadequacy of the theories, the limitation of the understanding. The mountains that shouldn't exist are a monument to the surprise. They are a reminder that the universe is not bound by our expectations, that reality is stranger than fiction, that there are forces at work that we do not see, that the darkness is not empty, it is full of power, and the power is terrifying. Because if Pluto can generate this power, what else can? What other worlds are hiding this power? What other worlds are alive in the dark? The mountains are not just rock. They are a signal, a beacon, a warning that we do not know the solar system, that we do not know the rules, that we are just beginning to learn. Chapter 6, The Red Stain. Pluto is red, not the red of Mars, the red of rust, the red of blood, the red of tholins. Tholins are complex organic molecules created when ultraviolet light hits methane and nitrogen. They break the bonds. They rearrange the atoms. They form long chains, polymers, macromolecules. They are sticky. They are dark. They are red. They cover the surface. They coat the ice. They create the color. But the red is not uniform. It is patchy. It is concentrated in the equatorial regions, in the dark areas, in the Cthulhu macula, the whale, a large dark region along the equator. It is covered in tholins. It is old. It is cratered. It is the ancient crust, the original surface. The rest has been covered, resurfaced, renewed, but the whale remains, a reminder of the past. The tholins are also in the atmosphere. The haze, the blue sky, the particles settle, they rain down, they cover the surface, they are everywhere. They are the product of radiation, of energy, of chemistry. They are the precursors to life, the building blocks, the ingredients. Pluto is covered in the stuff of life. But there is no life, or is there? The red stain is also a chemical factory. The radiation breaks the molecules. The heat reforms them. The ice protects them. The subsurface ocean mixes them. The cryovolcanoes bring them up. It is a cycle, a reactor, a laboratory, creating complex organics, billions of years, trillions of tons. The Kuiper Belt is full of this stuff. It is delivered to the inner planets by comets, by asteroids, by dust. Pluto is a source, a factory, a supplier. The red stain is also a mystery. The composition is not fully known. The spectra are complex, overlapping, ambiguous. We know there are tholins, but what kind? What size? What structure? Are they biologically relevant? Are they just tar? Or are they something more? The data is not clear. The instruments were not designed for this. They were designed for ice, for rock, for gas, not for organics, not for life. The red stain is also a marker of age, of exposure. The more red, the older the surface, the more radiation, the more time. The white areas are young. The red areas are old. It is a clock, a timer, a history. We can date the surface by the color. The heart is white. It is young. The whale is red. It is old. The mountains are white-topped. They are new. The valleys are red. They are old. It is a map of time. But the red stain is also unsettling. It looks like blood. It looks like violence. It looks like danger. It is the color of warning, of toxicity, of poison. Tholins are not good for life. They are carcinogenic. They are mutagenic. They are harmful. Pluto is covered in poison, but it is also covered in potential, in possibility, in hope. It is a contradiction, a paradox, a danger and a promise. The red stain is the face of Pluto. It is what we see. It is what we remember. It is the icon, the symbol, the brand. But it is also the mask, hiding the truth, hiding the ice, hiding the ocean, hiding the activity, hiding the terror. The red stain is the cover, the surface, the skin, but beneath it is the muscle, the bone, the heart, the engine. The scientists studied the red stain. They analyzed the spectra. They modeled the chemistry. They tried to understand the formation. But there were anomalies. The distribution was not random. It was structured, patterned, aligned. With the magnetic field? With the winds? With the currents? It was not clear. There were hints, suggestions, clues, but no proof. The red stain is a reminder of the complexity of Pluto. It is not just ice. It is chemistry. It is organic. It is complex. It is rich. It is diverse. It is a world of many faces, many colors, many layers, many secrets. And the red stain is the most visible secret, the one we can see, the one we can touch, the one we can study. But it is also the one we do not understand. Chapter 7. The subsurface ocean. The most terrifying discovery of all was not on the surface, it was beneath it. The subsurface ocean. The evidence was indirect, but strong. The reorientation of the heart, the tectonic stresses, the cryovolcanism, the heat flow, all pointed to a liquid layer, a global ocean. Beneath the ice, water, salty, ammonia-rich, liquid. This was shocking. Pluto is small. It should have frozen. The heat should have escaped. The water should be ice, but it is not. It is liquid. How? The antifreeze, the ammonia, lowering the melting point, the insulation, the clathrates, trapping the heat, the radioactivity, generating the warmth. It is a combination, a perfect storm, an unlikely set of conditions. But it is there. The ocean is deep, hundreds of miles, more water than Earth, more water than all the oceans on Earth combined. Pluto is a water world, a wet world, a hidden ocean, in the dark, in the cold, in the void. It is a miracle of physics, a miracle of chemistry, a miracle of survival. But the ocean is also a habitat, a potential habitat for life. Microbial, simple, primitive, but life. The ingredients are there, the water, the organics, the energy, the heat, the chemistry, everything needed for life. Is it there? We do not know. We cannot see. We cannot sample. We cannot drill. We can only infer. We can only guess. We can only hope. The possibility of life is the terror, not because the life is dangerous, but because the implication is profound. If life exists on Pluto, it exists everywhere. The habitable zone is not a zone. It is a volume. It is the whole solar system. It is the whole galaxy. It is the whole universe. Life is not rare. It is common. It is ubiquitous. It is inevitable. We are not special. We are not unique. We are not alone. This is the Copernican principle again. We are not the center. We are not the focus. We are not the goal. We are just one example, one instance, one data point, in a universe full of data points, full of life, full of worlds, full of oceans. The subsurface ocean is also a mystery. How old is it? Is it primordial? Or is it recent? Did it freeze and melt? Did it cycle? Did it evolve? Did it change? We do not know. We have one snapshot, One moment, one time. We do not have the history. We do not have the timeline. We do not have the context. The ocean is also a shield, protecting the surface from radiation, from impacts, from the void. It is a buffer, a layer, a barrier. It separates the core from the crust. It decouples the interior from the exterior. It allows the movement, the reorientation, the activity. It is the engine, the motor, the power. But the ocean is also hidden, invisible, untouchable. We know it is there, but we cannot see it. We cannot measure it. We cannot sample it. It is a ghost, a phantom, a presence without a form. It is known by its effects, by its shadows, by its traces, but not by itself. The scientists debated the ocean. They argued about the depth, the composition, the temperature, the salinity. They modeled the convection, the currents, the mixing. They tried to understand the dynamics, but it was speculative, theoretical, mathematical, not empirical, not observational, not direct. The subsurface ocean is the heart of the terror. It is the source of the activity, the source of the heat, the source of the mystery. It is the unknown, the hidden, the dark. It is what lies beneath. And what lies beneath is always more terrifying than what lies on top. Because we cannot see it. We cannot control it. We cannot predict it. It is the abyss. And it is looking back. Chapter 8. The anomaly in the data. And then there was the anomaly. The thing that was not published. The thing that was whispered. The thing that was kept quiet. In the data from the SWAP instrument. The solar wind around Pluto. It measured the interaction of the solar wind with Pluto's atmosphere. It measured the escape rate, the loss of gas, the size of the tail, but there was a spike, a burst, a signal, not from the solar wind, not from the atmosphere, from the surface. A localized emission, a burst of energy, a heat signature, too hot, too bright, too fast. It lasted for minutes, then it was gone. It was not repeated. It was not seen again. It was a glitch, a cosmic ray, an instrument error. The team investigated. They checked the calibration. They checked the background. They checked the other instruments. Nothing. Only SWAP. Only that moment. Only that location. Near the heart. Near the edge of the Sputnik Planitia. They could not explain it. It did not fit the models. It did not fit the physics. It was an outlier, a statistical impossibility, a 1 in a million chance. But it was there, in the data, real, recorded, verified. They debated what to do. Publish it? Ignore it? Classify it? It was not conclusive. It was not proof. It was a hint, a whisper, a clue, but it was dangerous. It could be misinterpreted. It could be sensationalized. It could be used to support pseudoscience, aliens, UFOs, conspiracy theories. So they decided to wait, to analyze more, to find more evidence, to be sure. But the data was limited. The flyby was over. The spacecraft was moving away. There would be no more data, not for decades, not until the next mission, if there was a next mission. So the anomaly remained, in the archives, in the servers, in the minds of the scientists. A secret, a mystery, a terror. What was it? A cryovolcano erupting? A plume of water? A vent of gas? A release of energy? Or something else? Something unknown? Something unnatural? The anomaly was the seed of the fear, the doubt, the uncertainty. It was the crack in the certainty, the hole in the knowledge, the gap in the understanding. It was the thing that kept them awake, the thing they did not talk about, the thing they did not write about, the thing that was terrifying, Because if it was real, if it was not a glitch, if it was a phenomenon, then Pluto was more active than we thought, more energetic, more powerful, more dangerous. It was not just alive, it was volatile, unstable, unpredictable. It was a threat, not to Earth, but to the models, to the theories, to the understanding. The anomaly was the shadow of the discovery, the dark side of the light, the hidden truth, the thing beneath the surface, the thing beneath the ice, the thing beneath the ocean, the thing that was waiting, watching, listening. The scientists knew. They knew something was there, something in the data, something in the dark, something on Pluto. And they were afraid, not of the object, but of the implication, of the meaning, of the consequence. The anomaly was the end of the beginning, the start of the fear, the trigger of the terror. It was the thing that changed everything, the thing that made Pluto not just a discovery, but a warning, a signal, a message, from the edge, from the dark, from the deep. And the message was clear. We are not alone. We are not safe. We are not sure. We are not ready. We are just beginning, and the universe is watching. Chapter 9. The ice volcanoes. The mountains were shocking, but the volcanoes were impossible. On Earth, volcanoes are engines of fire. They are the vents of the planet's internal heat, spewing molten rock, ash, and gas into the sky. They require immense temperatures, melting points exceeding 2,000 degrees Fahrenheit. They are the signature of a hot, dynamic interior. But on Pluto, there is no fire. There is no molten rock. There is only ice. And yet, New Horizons found volcanoes. Wright Mons, Pickard Mons, two massive structures rising from the southern plains. They are not mountains formed by collision or uplift. They are volcanoes formed by eruption. But they do not erupt lava. They erupt cryomagma, a slurry of water ice, ammonia, methane, and nitrogen, a liquid that flows at minus 300 degrees Fahrenheit, a substance that is solid rock in our world, but fluid mud in theirs. Wright Mons is 4 kilometers high, 150 kilometers wide. It has a summit depression, a caldera, not formed by impact, but by collapse, by the draining of a magma chamber, by the eruption of ice. The discovery of cryovolcanism on Pluto was a paradigm shift. Before New Horizons, cryovolcanism was theoretical. It was predicted for Titan, for Enceladus, for Europa, moons of giant planets heated by tidal forces. But Pluto is not a moon. It is a dwarf planet. It orbits the sun directly. It has no giant planet to squeeze it, no tidal flexing to generate heat. It should be cold. It should be solid. But Wright Mons says otherwise. It says there was heat, there was pressure, there was eruption. The morphology of the volcanoes tells the story. The slopes are smooth, hummocky, covered in flows. Not lava flows, but ice flows, viscous, slow, like glaciers, but moving uphill, pushed by pressure from below. The material is water ice, but pure water ice is too stiff. It would not flow. It would plug the vent. It would freeze instantly. There must be antifreeze, ammonia, methanol, salts, lowering the melting point, keeping the slurry liquid long enough to erupt, long enough to build a mountain. The age of the volcanoes is the terrifying part. They are not ancient. They are not relics of the early solar system. They are young, geologically recent, perhaps less than 1 billion years old, perhaps much less. The crater count is low. The surface is fresh. This means Pluto was erupting recently. It means the interior was hot recently. It means the engine is still running, or at least it was running yesterday. In cosmic time, yesterday is now. The energy required for this eruption is staggering. To melt water ice at that distance, to push it through a crust 10 miles thick, to lift it 4 kilometers into the air requires energy. Massive amounts of energy. Where did it come from? The radioactive decay in the core is insufficient. The models say it should have run out billions of years ago. The tidal heating is negligible. The orbit is too circular. The sun is too far. The math does not work. The energy budget is in deficit. And yet, the volcano stands. This implies a mechanism we do not understand, a process we have not modeled. Perhaps the insulation is better than we thought. Perhaps the clathrate layer is thicker. Perhaps there is a chemical reaction in the core we have not considered. Exothermic reactions, serpentinization, the interaction of water and rock releasing heat, but even that has limits. Even that runs out. But Pluto persists. The volcanoes are also vents for the atmosphere. They release gas, volatiles, replenishing the thin veil of nitrogen. They are the lungs of the world, breathing out into the void, connecting the interior to the exterior, the ocean to the space. They are the conduits, the pathways. If life exists in the ocean, this is how it could escape. This is how the biosignatures could reach the surface. This is how we could detect them. But the volcanoes are silent now, dormant, or dead. We do not know. There is no heat signature detected, no active plume, no glow, just the cold structure, the fossil of an eruption, but a recent fossil, like a dinosaur bone that is still warm. It suggests the potential for reawakening, the potential for future eruptions, the potential for change. The existence of right mons challenges the definition of a planet. A planet is a body that has cleared its orbit. A dwarf planet has not. But a dwarf planet that has volcanoes, that has geology, that has an atmosphere, that has weather, it blurs the line. It makes the classification seem arbitrary. Pluto is more alive than Mars, more active than Mercury, more complex than the Moon, and yet it is not a planet. The taxonomy of the solar system is broken. The E categories are insufficient. The reality is too messy. The ice volcanoes are a testament to the resilience of matter, to the power of pressure, to the persistence of heat. They show us that even in the coldest place, warmth can find a way. Even in the deepest freeze, energy can accumulate. Even in the dead of night, fire can burn. But it is a cold fire, a dark fire, a fire of ice, and it is terrifying because it defies our intuition. It tells us that our understanding of heat and cold is relative, that what is dead to us may be alive to them, that what is frozen to us may be fluid to them. The scientists studied the volcanoes with a mix of awe and frustration. Awe at the beauty, the scale, the uniqueness, frustration at the lack of answers. The data was limited. The resolution was not high enough to see the details. The vents were not clear. The flows were ambiguous. They had to infer, they had to model, they had to guess. And the guesses were uncomfortable. They required stretching, the physics, bending the rules, accepting the improbable. The volcanoes are also a target for future exploration, a landing site, a place to sample. The material erupted from the interior is pristine, unweathered, unradiated. It is a direct sample of the ocean. If we want to know what is in the ocean, we do not need to drill. We need to collect the snow, the frost, the ash from the volcano. It is there on the surface, waiting. But the volcanoes are dangerous. The terrain is rough. The slopes are steep. The ice is hard. A landing would be risky. A sample return would be complex. The gravity is low, the escape velocity is low, but the distance is high, the cost is high, the time is long. The volcanoes are a promise, but a distant promise. A promise for the next generation, for the children of the scientists who found them. The ice volcanoes of Pluto are a monument to the unknown. They stand in the dark, silent, cold, but alive with potential. They are the guardians of the ocean, the keepers of the heat, the witnesses to the history, and they are waiting for us to return, to ask the questions, to find the answers, to understand the fire of ice. Chapter 10. The Charon connection. Pluto does not orbit alone. It has a partner, a dance partner, Saturn, the largest moon in the solar system relative to its parent. Half the size of Pluto, 1/8 the mass. They orbit a barycenter, a point of gravity between them. Outside Pluto's surface, they are a binary system, a double planet. They are tidally locked, facing each other, always, never turning away. An eternal gaze, a cosmic stare. Charon is not just a moon, it is a world, a complex world, with its own geology, its own history, its own mysteries. When New Horizons flew by Pluto, it also flew by Charon, and what it found was just as surprising, just as terrifying. Charon has a red pole, a dark cap, Mordor macula. The name is fitting, the land of shadow, the place of darkness. It is red, like Pluto, like blood, like Tholins. The red pole is a mystery. How did it get there? The theory is atmospheric theft. Pluto has an atmosphere. Charon does not. But Pluto's atmosphere escapes. It leaks into space. The nitrogen molecules drift away. Some of them are captured by Charon's gravity. They fall to the pole, the winter pole, where the sun does not shine for decades. They freeze, they accumulate, they are hit by radiation. They turn into tholins. They turn red. When the sun returns, the ice sublimates, but the tholins remain, a stain, a cap, a record of the theft. This connection is intimate. Pluto is feeding Charon, losing its atmosphere to its partner. A slow suicide, a transfer of mass, a chemical bond. They are linked, not just by gravity, but by material, by atmosphere, by history. They are a system, a single entity, and what happens to one affects the other. Charon also has canyons. Serenity Chasma, 4 miles deep, longer than the Grand Canyon. It runs along the equator, a belt of violence. It suggests expansion. The interior froze, the water expanded, the crust cracked, the planet swelled. It tore itself apart. It was a violent birth, a violent growth, a violent history. But Charon also has smooth plains, Vulcan planitia, resurfaced, young, like Pluto, like the heart. It suggests activity, cryovolcanism, resurfacing, flow. Charon was alive too, or is still alive. The heat source is the same mystery, radioactivity, tidal heating, past tides. The orbit was different once, more eccentric, more elliptical. The tides were stronger, the heat was greater, but the orbit is circular now. The tides are weak, the heat should be gone, but the evidence remains. The binary system also affects Pluto's stability. The wobble, the precession, the axial tilt. Charon stabilizes Pluto. It keeps the axis steady. It prevents chaotic tumbling. Like the moon does for Earth, it creates seasons, long seasons, decades of light, decades of dark. The climate is driven by the orbit, by the distance, by the tilt. The heart beats in rhythm with the partner. The connection is also gravitational. The tides raise bulges. On Pluto, on Charon, they stretch each other. They deform each other. They generate heat, friction, internal friction, but not enough. Not now, but maybe in the past. Maybe the heat is residual, trapped, insulated. But the timing is wrong. The activity is too recent. The heat should have dissipated. The Charon connection raises the question of habitability. If Pluto has an ocean, does Charon? The evidence suggests yes. The expansion, the cracking, the resurfacing, two oceans in the same system, orbiting each other, communicating through atmosphere, through gravity, through history, a dual biosphere, a shared potential. The red pole of Charon is a warning. It shows the loss, the escape, the fragility. Pluto is losing its air, slowly but surely. In 1 billion years, it will be gone, frozen, deposited, on Charon, on the surface. The atmosphere is temporary. The life is temporary. The heat is temporary. Everything fades, everything freezes, everything ends. The scientists studied the pair with a sense of duality. Two worlds, one story, mirroring each other, reflecting each other. The light and the dark, the heart and the pole, the ice and the red. They are a couple, a binary star of ice, and their dance is a story of survival, of connection, of loss. The Charon connection is a reminder that nothing exists in isolation. Not in the solar system, not in the universe. Everything is linked by gravity, by material, by history. Pluto is not alone. Charon is not alone. They are together, in the dark, facing each other, waiting, watching, holding hands across the void. And the red stain on Charon is a mark of that bond, a blood pact, a transfer of life, a sharing of fate. It is beautiful. It is tragic. It is terrifying, because it shows the impermanence, the decay, the end, the slow freeze of the system, the death of the atmosphere, the silence of the ocean, the final stillness. Chapter 11, the Kuiper Belt Context. Pluto is not an outlier. It is a representative, a sample, of the Kuiper Belt, the third zone of the solar system, beyond the rocky planets, beyond the gas giants, the realm of ice, of darkness, of cold. For decades, we thought it was a graveyard, a collection of dead rocks, debris, leftovers, unimportant. But Pluto changed that. If Pluto is alive, what about the others? New Horizons flew past Pluto, but it did not stop. It continued. Into the Kuiper Belt, to Arakoth, Ultima Thule. A contact binary, two lobes joined together, pristine, unchanged since the beginning. It was cold, dead, inactive, no atmosphere, no geology, no heat. It was what we expected, a fossil, a relic. But Arakoth is small, 5 times smaller than Pluto. Perhaps size matters. Perhaps only the large objects retain heat. Only the massive ones hold oceans. Eris, Makemake, Haumea? They are similar in size to Pluto. Are they active? We do not know. We have no data, no images, no spectra, just points of light. But the models suggest yes. The physics suggests yes. If Pluto has an ocean, they should too. The insulation, the antifreeze, the radioactivity. It should apply to all. The Kuiper Belt may be a ring of living worlds, dozens, hundreds, hidden in the dark, each with an ocean, each with potential, each with heat. A hidden biosphere, a shadow ecosystem, surrounding the solar system, a ring of life in the freeze. This changes the census of habitable worlds. We used to count the Earth, maybe Mars, maybe Europa, maybe Enceladus. Now we add Pluto, Charon, Eris, Makemake, Haumea, Quaoar, Sedna. The list grows. The habitable zone expands. It is not a zone, it is a volume. It is the whole system. The density of objects in the Kuiper Belt is also a mystery. We thought it was crowded. New Horizons found it empty, clean, low dust, low debris, this suggests the objects are old, unchanged, not colliding, not grinding down, preserved. But it also suggests the formation was different, the dynamics were different, the history was different. The Kuiper Belt is also a source of comets, of water, of organics. It delivered the ingredients to Earth, the water in our oceans, the carbon in our cells. It came from here, from the dark, from the cold. Pluto is a sibling, a brother, a supplier. We are made of Kuiper Belt stuff. We are connected by material, by history, by origin. The context of the Kuiper Belt makes Pluto less unique, but more significant. It is the key, the unlock, the first data point, the first proof. If Pluto is active, the belt is active. If Pluto has an ocean, the belt has oceans. If Pluto has potential, the belt has potential. The scientists look at the Kuiper Belt with new eyes, not as a debris field, but as a neighborhood, a community of worlds, of oceans, of secrets. They want to go back. They want to visit Eris. They want to orbit Make. They want to land on Haumea. They want to know. They want to confirm. They want to count. But the distance is the barrier. The time is the enemy. The cost is the limit. We cannot visit them all. We cannot sample them all. We have to choose. We have to prioritize. And Pluto was the choice, the king, the first, the best. The Kuiper Belt context is the expansion of the terror. It is not just one world. It is many. It is not just one ocean. It is many. It is not just one potential. It is many. The darkness is full. The cold is warm. The dead are alive. The silence is loud. And the Kuiper Belt is just the beginning. Beyond it lies the Oort cloud, the sphere of comets, the edge of the sun's influence. Are there worlds there? Planets? Planet 9? The hypothetical giant. Hiding in the dark? Pulling the orbits? Shaping the belt? Is it alive too? Does it have an ocean? Does it have heat? The Kuiper Belt context is a door, opened by Pluto, leading to the wider darkness, to the deeper mystery, to the greater terror. That we are surrounded by worlds, by oceans, by potential, and we are just beginning to see. Chapter 12, the energy paradox. The core of the terror is the energy, the heat, the power. Pluto should be cold. It is small. It is far. It is old. The heat from formation should have radiated away billions of years ago. The radioactive decay should have ceased. The isotopes should have died. The tidal heating should be negligible. The sun should be irrelevant. The energy budget should be zero. But it is not. It is positive. It is active. It is alive. This is the energy paradox. The impossible heat. How is Pluto warm? The models say it should be frozen. The data says it is not. The discrepancy is huge, unexplainable. It requires new physics, or unknown mechanisms, or hidden sources. The radioactive elements, aluminum-26, potassium-40, thorium, uranium. They decay, they release heat, but the abundance in Pluto is low. It is a small body. It did not accrete enough rock, enough metal, enough isotopes. The heat production is insufficient. It should have frozen in 1 billion years. But it is still warm. The tidal heating, the orbit is circular, the eccentricity is low, the tides are weak, the flexing is minimal, the friction is low, the heat generation is negligible. But maybe the orbit was different. In the past, more elliptical, more chaotic. The tides were stronger, the heat was greater. But that was billions of years ago. The heat should have dissipated, unless it is stored, trapped, insulated. The insulation, the clathrate hydrates, the gas ice, the blanket, it traps the heat. It prevents the escape. It keeps the ocean liquid. It extends the life. But for how long? 1 billion years? 2? Not 4? Not 5? Not the age of the solar system. The blanket should have leaked. The heat should have escaped. But it has not. The chemical reactions, serpentinization, the water and rock, the exothermic process, the release of heat, but it requires water and rock and contact, and it runs out. When the rock is altered, the reaction stops. The heat ceases. It is not sustainable, not for billions of years. The impact heating, the formation of the heart, the collision, the melt, the energy. But that was a single event, a spike, not a continuous source. The heat should have cooled. The ocean should have frozen. But it is liquid. The energy paradox is a crisis for planetary science, for thermodynamics, for physics. It suggests we are missing something, a variable, a factor, a process, something fundamental, something basic, something we overlooked. Perhaps the radioactivity is higher, the concentration is greater, the differentiation was different, the core is richer. But why? How? The formation models do not support it. The accretion models do not support it. Perhaps the insulation is better, the crust is thicker, the clathrates are more efficient, the conductivity is lower, but the measurements say otherwise. The thermal models say otherwise. Perhaps the tides are stronger, the interior is softer, the dissipation is higher, but the orbit says otherwise. The dynamics say otherwise. The energy paradox is the heart of the fear. It is the unknown, the unexplained, the impossible. It is the gap in the knowledge, the hole in the understanding, the failure of the theory. And it is terrifying because it implies our physics is incomplete. Our models are wrong. Our understanding is flawed. The scientists debate the paradox. They argue, they propose, they test, but no solution fits, no model works, no theory holds. The energy remains a mystery, a secret, a terror, and the energy is the key to the ocean, to the activity, to the life. Without the energy, there is no heat. Without the heat, there is no ocean. Without the ocean, there is no life. The energy is the source, the engine, the power. And we do not know where it comes from. The energy paradox is a warning that we do not understand the universe, that we do not understand the heat, that we do not understand the cold, that we are children, playing with fire, in the dark, and the fire is burning, but we do not know why. Chapter 13, The Search for Life. The implication of the ocean is life. If there is water, there is life. On Earth, wherever there is water, there is life. In the deep sea, in the ice, in the acid, in the heat, life finds a way. It adapts. It survives. It thrives. So if Pluto has water, does it have life? The conditions are harsh, cold, dark, high pressure, low energy. But life on Earth survives harsh conditions. Extremophiles, thermophiles, psychrophiles, organisms that live in ice, in darkness, in heat, in pressure. They do not need sunlight. They need chemistry, chemotrophy. They eat rock. They eat sulfur. They eat hydrogen. They breathe iron. They are alien, but they are here, on Earth. So why not on Pluto? The ingredients are there, the water, the organics, the energy, the heat, the time. 4 billion years, enough for evolution, enough for complexity, enough for life. But the life would be different, alien, microbial, simple, hidden, in the ocean, beneath the ice, in the dark. It would not be intelligent. It would not be technological. It would not be visible. It would be silent, invisible, undetectable, unless it leaves a trace, a biosignature, a gas, a chemical, a ratio, an anomaly. The search for life on Pluto is the search for the anomaly, the thing in the data, the spike in the swap instrument, the burst of energy, the unexplained emission. Is it life? Is it biology? Is it metabolism? Or is it geology, chemistry, physics? We do not know. We cannot tell. The instruments were not designed for life. They were designed for ice, for rock, for gas. Not for cells, not for DNA, not for biology. The search is also philosophical. What is life? Is it carbon-based? Is it water-dependent? Is it Earth-like? Or is it something else? Something exotic, something we cannot imagine, something that does not need water, something that does not need heat, something that lives in the ice, in the rock, in the void. The possibility of life on Pluto changes everything. It means life is common. It means life is easy. It means life is inevitable. It means we are not special. We are not unique. We are not alone. It means the universe is full of life, full of biology, full of consciousness. And we are just one example, one instance, one data point. This is the Copernican principle again. We are not the center. We are not the focus. We are not the goal. We are just here, by chance, by luck, by accident. And there are others, everywhere, in the dark, in the cold, in the ice. The search for life is also dangerous. If we find it, what do? Do we protect it? Do we study it? Do we contaminate it? Do we destroy it? The planetary protection protocols are strict, but they are for Mars, for Europa, for Enceladus, not for Pluto, not for the Kuiper Belt. The rules are not written. The ethics are not defined. The consequences are not known. The search for life is the ultimate goal, the holy grail, the dream, the terror. Because if we find it, we are not alone. And if we are not alone, we are not safe. We are not special. We are not unique. We are just part of the crowd, part of the noise, part of the universe. The scientists search for life with caution, with hope, with fear. They analyze the data. They look for the signs. They model the chemistry. They simulate the biology. They try to understand. They try to know. They try to find. But the search is hard. The distance is far. The data is limited. The signals are weak. The noise is high. The ambiguity is great. It is like looking for a needle in a haystack, in the dark, in the cold, in the void. The search for life on Pluto is a search for ourselves, for our place, for our meaning, for our purpose. Are we alone? Or are we part of a family, a community, a galaxy, a universe of life? Chapter 14. The Future Missions. New Horizons was a flyby, a glance, a touch. It was not enough. It was a teaser, a preview, a promise. To understand Pluto, we need to stay. We need to orbit. We need to land. We need to sample. We need to drill. We need to know. The Pluto Orbiter Mission. A concept, a dream, a proposal, a spacecraft that goes to Pluto, enters orbit, maps the surface, studies the atmosphere, samples the ice, drills the crust, searches for life. It would be the ultimate mission, the grand finale, the completion. But it is hard. The distance is far. The time is long. The cost is high. The power is low. The communication is slow. The navigation is precise. The risk is great. The technology is advanced. The will is weak. The propulsion. Chemical rockets are too slow. Nuclear electric propulsion. Ion drives. Solar sails. Laser sails. Faster. More efficient. But complex. Expensive. Unproven. The power. Solar panels do not work. RTGs are scarce. Plutonium is limited. Dangerous. The communication. The bandwidth is low. The latency is high. The data rate is slow. The download takes years. The patience is required. The landing, the gravity is low. The surface is hard. The ice is cold. The terrain is rough. The volcanoes are steep. The heart is smooth. But the temperature is low. The electronics freeze. The batteries die. The motors stick. The landing is risky. The survival is uncertain. The science, the instruments, the spectrometers, the cameras, the drills, the samplers, the life detectors, the biology labs, the chemistry sets, the physics tools, they must be miniaturized, automated, robust, reliable. They must work in the cold, in the dark, in the void. The cost? Billions. 10 billion. 20 billion. The budget? The politics? The priority? The competition? Mars? The Moon? Europa? Enceladus? Titan? They're closer, easier, cheaper, more popular. Pluto is far, hard, expensive, unpopular. A dwarf planet, not a planet, not worth the cost. Or is it? The will? The public? The scientists? The politicians? The taxpayers? Do they care? Do they want to know? Do they want to spend? Do they want to explore? Or do they want to stay home, to fix Earth, to solve problems, to survive? The future missions are a test of our commitment, of our curiosity, of our courage, of our humanity. Do we want to know? Do we want to explore? Do we want to understand? Or do we want to remain ignorant, safe, home? The scientists advocate for the mission. They propose, they lobby, they argue, they fight, they want to go back, they want to know, they want to find, they want to solve the paradox, they want to find the life, they want to complete the story. But the time is long. 20 years, 30 years, a generation. The scientists who proposed it will be dead. The engineers who built it will be retired. The children who watch the launch will be adults. The data will arrive when they are old. It is a legacy mission for the future, for the next generation, for the children of humanity. The future missions are a hope, a dream, a promise that we will return, that we will know, that we will understand, that we will not forget, that we will not stop, that we will continue to explore, to discover, to learn. Chapter 15. The cosmic implications. The discovery on Pluto is not just about Pluto. It is about the universe, about the cosmos, about the reality. It changes our understanding of habitability, of life, of heat, of energy, of physics. It expands the possibilities. It widens the scope. It deepens the mystery, the habitable zone, the Goldilocks zone, the region where water is liquid, where life can exist. Around a star, it is a lie, a simplification, a myth. Pluto is outside the zone. Far outside, frozen, dark, cold. But it has liquid water. It has heat. It has potential. It has life. The zone is not a zone. It is everywhere. It is internal. It is geological. It is tidal. It is radioactive. It is chemical. It is not about the star. It is about the world. This means exoplanets, planets around other stars, the ones we find, the thousands, the millions, the billions. They may not need to be in the zone. They may be far out, cold, dark, frozen, but alive, with oceans, with heat, with life. The number of habitable worlds increases exponentially. The universe is full of life, full of biology, full of consciousness. The Fermi paradox. Where is everybody? If life is common, why have we not heard from them? Why is the sky silent? Why is the universe quiet? Maybe they are like Pluto, hidden, in the dark, in the cold, in the ice, not broadcasting, not signaling, not traveling, just surviving, just living, just being, in the dark, the great filter, the barrier to civilization, to technology, to expansion. Maybe the filter is the cold, the dark, the isolation, the energy. It is hard to become technological in the dark. It is hard to expand from the ice. It is hard to leave the ocean. The filter is the environment, the condition, the limit, the cosmic. Implications are profound. They change our place, our status, our importance. We are not the center. We are not the goal. We are not the unique. We are just one of many, one of the lucky, one of the warm, one of the light. The discovery on Pluto is a mirror, reflecting the universe, reflecting the life, reflecting the potential, reflecting the mystery, reflecting the terror, that we are small, that we are brief, that we are alone, but not alone, that we are connected by the ice, by the water, by the heat, by the life. The scientists look at the cosmos with new eyes, not as a void, but as a garden, a forest, a field, of worlds, of oceans, of life. They see the potential, the possibility, the promise. They see the future, the exploration, the discovery, the understanding. The cosmic implications are a call to look up, to search, to find, to know, to understand, to connect, to be part of the universe, to be part of the life, to be part of the story. Conclusion: the story of Pluto is not over. It is just beginning. The data is still being analyzed. The models are still being refined. The theories are still being debated. The mystery is still unsolved. The terror is still present. The wonder is still alive. NASA discovered something terrifying on Pluto. Not a monster, not a weapon, not a threat, but a truth, a reality, a fact, that the universe is stranger than we imagined, that the darkness is full of light, that the cold is full of heat, that the dead are full of life, that the silence is full of sound. This truth is terrifying because it changes everything. It changes our understanding, our models, our physics, our biology, our philosophy, our place, our meaning, our purpose. It changes us, but it is also beautiful because it shows the potential, the diversity, the complexity, the richness, the wonder, the magic, the mystery. The universe is not a machine. It is an organism, a system, a life, and we are part of it. The New Horizons spacecraft is still flying, still moving, still exploring, still sending data, still telling the story. It is a messenger, a probe, a pioneer, a hero. It will continue until the power fails, until the fuel runs out, until the cold wins, until the silence returns. But the legacy will remain: the data, the images, the discoveries, the questions, the answers, the terror, the wonder, the story. It will be taught. It will be studied. It will be remembered. It will be told to the children, to the grandchildren, to the future. Pluto is not a dwarf planet. It is a world, a living world, a breathing world, a beating heart, in the dark, in the cold, in the void, and it is waiting for us, for the return, for the answer, for the understanding. We looked at the edge, and the edge looked back. We saw the terror, and the terror saw us. We found the life, and the life found us. We are not alone. We are never alone. We are part of the universe, and the universe is part of us. The discovery on Pluto is a reminder that there is more to know, more to see, more to find, more to understand, more to explore, more to discover, more to love, more to fear, more to be. So we look up, we search, we wonder, we wait, we hope, we dream, we explore, we discover, we learn, we live, because the universe is waiting, and it is full of surprises, full of terror, full of wonder, full of life, and Pluto is just the beginning.